Hiya, welcome to the exact values video for the trigonometry topic in higher mathematics. There will be some aspects that may be revision here, but I'd imagine a lot of you haven't seen this before. Uh, so we're looking at calculating exact values for sine, cos and tan of angles, firstly for under 90 degrees and then for every other angle as well, and then using those exact values to solve simple trigonometric equations. Okay, now different people learn their exact values in different ways. What I'm going to do is I really like learning it from the very start. So all you need to remember is these two shapes. An equilateral triangle that's 2 units the whole way around. Okay. And a square that's 1 unit the whole way around. Now all we're going to do here is cut them in half. Okay, so the first one we're going to do is we're going to cut that there in half, and then we're going to cut this one in half diagonally. Okay, now if you can remember those shapes, that's all you need to do. And what I would do is I would copy those shapes down on your non-calculator paper and get them down and then get your triangles very quickly from there. Okay, so here, if that's 2 units, we know it's an equilateral triangle, so that's 60 degrees. We've cut this angle in half at the top, so that's 30 degrees. This was 2, this is 1. And doing a very simple Pythagoras, 2 squared subtract 1 squared, this side here is going to be root 3. Okay, so there you have a triangle, a right angle triangle, so you can use your SOHCAHTOA to get values for those sides. One here, we've cut this in half, so these two angles are 45 and 45. This is also 1 unit long, and then doing Pythagoras again, this is going to be root 2. Okay, and there we have a right angle triangle again, where you can get sine, cos, and tan using SOHCAHTOA of 45 degrees. So those two triangles, which are up there in that little box, those are the two triangles we can use. Okay, and from there we can calculate, in fact I'm going to go back, we can calculate like sine 60. Sine 60 here, if we want to know what sine 60 is, well 60 degrees is here, we know sine is opposite over hypotenuse, so the opposite is root 3, the hypotenuse is 2. So it's opposite over hypotenuse, so sine 60 has to be root 3 over 2. Cos 30, okay, well there's 30 degrees, we know cos 30 has to be adjacent over hypotenuse, so there's your adjacent, there's your hypotenuse, so that's also going to be root 3 over 2. And the 45, let's do tan 45. Tan 45 is opposite over adjacent, so there's 45 degrees, opposite is 1, adjacent is 1, so it's just 1 divided by 1, or 1. And then let's do one more, sine 45. 45 degrees, opposite over hypotenuse, so 1 over root 2. Now, if you can remember those basic triangles and apply them to that, there you go, that's your exact values. Okay, now what we also need to be able to do is find the exact values of angles above 90 or below 0. Okay, and what we're going to do is we're going to use exactly what we've just done alongside the cast diagram. If we're looking at sine 150, we know from our cast diagram that 150 degrees is in that second quadrant there, where sine is positive. So we know that sine 150 is going to give us a positive answer. Okay, so it's going to be a positive sign there. Now in that second quadrant is 180 take away A. We know the answer to that is 150, is 150 degrees, so A has to be 30 degrees, because that's what we're taking away from 180 to make 150. So it's plus sine 30, or a positive sine 30. Then we go back to our triangles, right? Sine 30, opposite is 1, hypotenuse is 2. So it's going to be positive, rubbish, sorry, it's going to be positive a half. Let's just get rid of that wee mistake. Okay, so that's just going to be a half. We're looking at positive sine 30. We know sine 30 is a half, so the answer is just a half. Cos 225, okay. Cos 225, we're in the cast diagram. We know that 225 is in between 180 and 270, so that's going to be in here, where cos is negative, so we're dealing with a negative cos. In that third quadrant is 180 plus A. So to get to 225, we have to add on 45 to 180. So cos 225 is the same as negative cos 45. And up there, cos 45, adjacent over hypotenuse, is just negative 1 over root 2. Root 300, cast diagram. 300 where tan is negative, so we're doing a negative tan, and in there it's 360, subtract A, so to get 300 we're subtracting tan 60. Go to your 60, opposite over adjacent, opposite is root 3, adjacent is 1, so just negative root 3 divided by 1, or just negative root 3. Okay, and you'll get more practice of that in class. Last thing I want to look at is solving equations for between 0 and 360. So we'll just keep it in degrees just now, but obviously we can be asked this in radians as well. For sine x is equal to root 3 over 2. Okay, now sine x is equal to root 3 over 2. Firstly, we're doing it between 0 and 360, so we know we're going to be in two quadrants. So sine the first and the second quadrant. We know as well that the x value for this is just going to be a and 180 minus a. For root 3 over 2, your exact value, okay, going back to your triangles, for root 3 over 2, we're looking at sine, so root 3 over 2, you want this to be the opposite, so that's 60, and hypotenuse is going to be 2, so it's going to be 60 degrees, and in the second quadrant, 120 degrees. Tan x equals negative 1. Okay, cast diagram, we're looking at negative, so it's the second quadrant and the fourth quadrant. Okay, for 1, we know that the angle is going to be 45 from our exact values. In that second quadrant, that makes 135, and the last quadrant is 315 degrees. Okay, so recognizing the exact value of 45 there, and then putting that 45 into our cast diagram. Now, the third one's slightly trickier. We're looking at cos x equals negative 1. Now, for sine and cos, 1 and negative 1 is a special value because that's at a maximum minimum of our graphs. And for 0, sine, cos, and tan are all special because that's at the kind of extremities of our quadrants as well. So the cos graph we know is this, negative 1 there, bang in the middle, so x has to equal 180 degrees. Okay, and there you go, that's it. So 3 things: being able to identify exact values for angles less than 90, for more complicated angles, and then use those exact values to solve some equations. Any issues? Ask your teacher. Cheers.